Every Python developer has this panic moment. You make a .env file, install python-dotenv, run your code, but it ignores your variables. Today, let's fix this mystery forever. Most developers mix up .env files with python-dotenv. These are different tools, but you need both to make variables work. Let's explore why this happens. Look at the core of Python's environment system. You can pull values directly from system memory using os.environ, but doing this manually is annoying. So we make a .env file. But this is just a plain text file on your drive. It doesn't instantly load into your runtime. That is why you need python-dotenv to actively inject the text. Here is the correct way to use python-dotenv. You import load_dotenv, and you must call it first. This securely loads those strings into your OS memory. The OS module's role is simple. It is only the access point. It cannot create variables or read files. It acts as a window into the RAM that python-dotenv populated. Let's see this in action. Here is how you access keys in memory. You use os.environ.get. If missing, it safely returns none instead of crashing your live app. This brings us to a major error. People constantly forget to load the .env file before they try to access the keys. Doing this returns a key error. This code fails because the flow is backwards. Asking for the key before explicitly loading the .env file returns nothing, instantly crashing your code. Instead, here is the right structure. This guarantees the environment is loaded beforehand. Load .env first, inject data, and then safely ask for your key. What about deployments? You should never use .env files natively in production. Locally, the file is great. But in production, you want dynamic cloud settings handled by your host. In production platforms, you define keys directly in the cloud dashboard. The prod keys inject automatically into the environment, keeping code completely clean. Never commit .env files to GitHub. This is a massive security risk that exposes passwords publicly. Add it to .gitignore, never share it, and use secrets managers. Let's look at a proper file structure that keeps variables secure. Sitting quietly alongside your root files is the .env file, fully protected by the .gitignore structure. Let's connect these pieces. .env files act purely as offline storage, python-dotenv acts as the dynamic loader, and the Python OS module acts as the native reader tool. Here is an example showing all elements working together. We import the loader and access tool, trigger the load function, and then safely fetch our API string. Let's tackle typical errors developers face. If you see a key error or none-type error, it means you attempted to grab secrets before the loader successfully initiated. Here is how you add strict error handling. Instead of hoping the value exists, we fetch it, and if it returns none, we actively raise a value error, stopping execution. There are alternative patterns for handling secrets that pro teams love. In modern Python, you see JSON files, or advanced managers like Pydantic that handle fast validation. Here is how to structure a system using multiple keys in a massive app. Instead of dropping OS calls everywhere, you make a main config dict that fetches and parses everything. In enterprise systems, use a raw secrets manager like AWS Secrets or Vault instead of text overrides. These platforms are immensely secure and dynamically rotate keys. Let's isolate specific use cases. Use os.environ exclusively to access keys in active memory. Use load_dotenv purely to parse text overrides. Use .env strictly as dev storage. Here is the simplest working snippet. It imports the bridge, imports native OS, triggers the load sequence, and cleanly prints the key, proving the pipeline functions. This is the standard workflow locally. Create the .env block, install python-dotenv, cleanly load variables early in code, access them securely, then run your logic. Let's review a classic folder map perfectly suited for .env data. Keep the .env file rooted alongside your primary exec file so the load function discovers it innately. When things fail, verify file locations. The best debugging strategy is to confirm the .env file is positioned correctly, check for invisible spaces, and ensure the load function fires earliest. Let's see how this exact layout wonderfully supports a Flask application. Flask needs os.environ natively for security walls, but you need files locally. Just load the dotenv script earliest. Here is how you utilize environment logic in an actual Flask engine. Initialize the web app and assign the secret key directly from the operating engine to strongly encrypt sessions. How variables natively run under the hood differs between operating environments. Windows machines use the set shell command, whereas macOS terminals natively use export. Here is how you rapidly set variables manually inside command terminals for testing. On Windows, just type set API key equals value. On Linux, type export API key. Let's outline the total picture. Storage lives in .env, loaders map variables, access is completely native, and you block files from version control repos forever. Still confused about parsing variables natively inside Python environments? Ask your questions inside the comments below, hit subscribe, and I will personally reply to help you. Happy coding!